In this video, you will see the hydration of an alkene and the steps to complete this reaction. The hydration of an alkene will help you achieve the production of alcohols through the addition of water directly to the carbon-carbon double bond. Once converted from alkenes, alcohols are utilized for many of life's necessities, including toiletries, pharmaceuticals, fuels, and the sterilization of hospital instruments. Also, alcohol's use in the process of alcoholic fermentation assists in the production of beverages like beer and wine. This reaction also includes the vital guidelines known as Markovnikov's rule. Here we have a simple example of the hydration of an alkene. The example that follows is the reaction of ethene with steam, the gaseous form of water, to create the end product ethanol. Step 1. Draw H2O in the form of H-OH. Place it above the double bond of the molecule it is reacting with. Step 2. Identify the carbon-carbon double bond and detach one bond. Step 3. Take the detached bond and connect it from the carbon of the alkene to the hydrogen of the water molecule above. Step 4. Detach the bond between the hydrogen and the hydroxide group of the water. Step 5. Reattach the detached bond from the hydroxide group of the water to the other carbon of the alkene below. The end product should be the alcohol ethanol, as stated in the beginning of the reaction. Hydration reactions are reversible, which is known as the dehydration of alcohols, identified by the forward and reverse arrows of the reaction.
In the case of asymmetric alkenes, according to Russian scientist Vladimir Markovnikov, when adding hydrogen across a carbon-carbon double bond, the hydrogen will always join the carbon with more hydrogens attached to it. In Professor Zovel's words, the rich get richer. When dealing with an asymmetric alkene, there is a potential to form two separate alcohols known as the major and minor products. Here's an example of the reaction between propene and water to manufacture 2-propanol and 1-propanol. Step 1. Draw the line bond structure of propene reacting with water. Following the same steps labeled above, continue with these added guidelines to obey Markovnikov's rule. Step 2. For the major product, add the hydrogen to the carbon with the most hydrogens attached to it. Hence, the rich get richer. Step 3. For the minor product, add the hydrogen to the carbon with the least hydrogens attached to it. Step 4. Form the major product 2-propanol as identified by the placement of the hydrogen over the wealthier carbon, and the minor product 1-propanol identified by the placement of the hydrogen over the poorer carbon. Let's see what you've comprehended. Here are some practice questions you can try. The first includes the reaction between 1-pentene and H2O. The second question will pertain to Markovnikov's rule and includes the reaction between 2-methyl-2-pentene and H2O. Remember to follow all rules and steps for successful response. Press pause and work on the problems. Using the steps from before, rewrite H2O as H-OH above the molecule in which you are going to react it with. Notice how in this reaction, the H connects to the carbon with the most amount of hydrogens connected to it, and the hydroxide group of the water connects to the carbon with the least amount of hydrogens connected to it, as shown in the answer. In this reaction, following the steps from before, and Markovnikov's rule, you will notice there are two separate products. The first product, the major product, rewrite the water as H-OH. Notice that the hydrogen connects to the carbon with the most amount of hydrogens connected to it. And the hydroxide group connects to the carbon with the least amount of hydrogens connected to it, as shown in the answer. For the minor product, simply flip the water molecule and you will see that the carbon with the most amount of hydrogens connected to it receives the OH. And the carbon with the least amount of hydrogens connected to it receives the hydrogen, as shown in the answer.